In this video I want to talk about floating point operations in Lucee. When you take this example, you will for sure expect that this operation gives this result. But when you execute that code, you are given that result. So you see it's not precise. You expected that is higher, but it's not rounded to that result. So we get a lot of complaints about this, that Lucee is not precise when it comes to math operations, and that is mostly based on a misunderstanding how math operations are working in programming language. That's not specific to Lucee or Java. That's in programming language in general. The reason for that is that when you execute code like this, you see you have in that case you have 3 operands, and these operands are stored in memory, and the result is stored in memory, and all this of course is stored in a binary form. So you don't store the number 100, that's 010101, something like that, in memory, and when the math operation is done on this representation of the numbers in the memory, and the result is also in memory. So what is going on in memory is completely different than what you see. What you see is always just a conversion of the binary number to a decimal number. So, and the problem is that the memory for a single number is limited in the storage. So there's always a limited precision when it comes to floating point number. So even a operation looks very simple in decimal format like this one. It can be completely different when it comes to the binary representation of the same number. That is the reason we see that that behavior in Lucee. I will link below a link to Stack Overflow that also shows in detail that problem. How you can solve that? There's a way. Maybe solve is the wrong problem, the wrong word. How you can improve that is the right term. So always, if you highly depend on the result of a mathematical operation, then use the function precision evaluate. That it uses more memory to store all the operands. So that's from docs.lucee.org, the description of the function. When you take that function, and I wrap that function around the math operation. Important here is that everything is happening, it has to be a string, so it has to be in quotes. So when I execute that math operation now, I'd have a syntax error. Let me correct that. There's one open. Okay, there's one missing. That's always the same. Okay, again. So you see, now I get the right result. So there's not really a solution for that, but precision evaluate makes it a much better. Okay, if you like that video, give it a thumbs up. If you have any question, please add a comment below.